Hi, this is video number 1 for trig unit number 4. It is graphing sine and cosine and changes in period and amplitude. I just want to take a second here to warn you that the start of video number 2, I accidentally misspoke. I actually recorded video 2 first, and now I'm recording video 1. And at the start of video 2, I claim that the title is video number 1. So just beware of that. The next time you watch a video, when it's supposed to be video number 2, at the start I say video 1, but it is not, okay? The way that it is labeled online is correct. Okay, so this lesson is going to be pretty short, and it's just going to be looking at a few more examples similar to the ones that we have done in class so far. We did a few examples the other day that were things like y equals 2 sine x and y equals -3 cosine x, along those lines. I just want to do a couple more of them to make sure we drive the point home, okay? Which is anything that's in this format. Oh, I kind of miswrote there. Okay, so my format, a little messy. Okay, y equals a sine a number times x, or that could be a cosine as well. Anything in these two formats we know some stuff about. We know that this number in the front, this a, is going to be the amplitude of our sine or cosine curve, okay? And the amplitude is how high and how low the hills and valleys go from the midline. And we know that this b value multiplied by the x is going to influence what the length of each wavelength of our sine curve or our cosine curve is going to be. And in fact, the relationship that we know is that the period, which is usually 2 pi units long, gets divided by whatever b is. So if b is 2, we take 2 pi divided by 2, then the period is only pi. And that would mean that our sine curve or our cosine curve oscillates more quickly. Let's just look at a couple of examples, and these might be repetitive from what we did in class. I have to admit I did not write down which examples we did. But in your notes packet, you just have some nice graph paper that's all set up. It looks just like what I have on my screen here, and we'll just do a couple together and call it a day, okay? So let's say that we have y equals 4. Let's do sine, and let's say we have 2x. All right? It would be helpful if you remembered what sine looks like, and if you don't, that's all right at this point. We can look back in our packet where we have our principal sine curves graphed out. So our sine graph looks like this when I look back at my packet of the basic trig graphs. And so now in my notes packet, I could graph this one, okay? So I'm kind of thinking you have the packet of trig graphs next to you, and then you have your notes for the video lesson also, okay? So when I look back at that principal packet, I can see that just y equals sine x with nothing else added to it looks about like that, okay? Now the fact that there's a 4 here means that my hills and valleys are going to go 4 times as high. The fact that there's a 2 right here makes me think, okay, well, since the b value is 2, that means that the period is going to be 2 pi over b, and b is 2. So the period here is just pi. So this is a graph that stretches 4 times as tall, but the period is half as much. I'm going to plot this point first. It's going to be right here. And this point on the green graph, this one, I'm going to have be just here. Instead of at 2 pi, it's only pi units wide. This point from my basic graph is going to be right here. And then I know that I have to go 4 units tall. So I'm going to go way up to here. Kind of overlaps my writing. And my low point is going to go way down here. And then I'm going to connect those up with as smooth of a curve as I can manage to draw. Okay, and there is one cycle of 4 sine 2x. And then I could repeat that cycle over and over if I needed to. Let's do another. Okay, let's do one that turns out a little bit tricky, okay? We'll take a hard example now. Let's still use sine. I kind of like using sine. But let's make it reflected. And let's put a kind of awkward number in here. Okay, we'll be brave. All right? So now our amplitude is going to be 3. The fact that this is negative is going to flip it over. So A is -3, meaning that the amplitude is 3, but the fact that it's negative means I have to flip the hills and the valleys. So that's a little bit trickier. My B value is also 3, which means that the period, which is found by doing 2 pi over B, is 2 pi over 3. Ooh, 2 pi over 3, how much is that? Well, think about your unit circle if you're a little bit stuck. We can go back and revisit the unit circle for a second. 2 pi over 3 is right here. So that's 120 degrees. So what we're saying with the period being 2 pi over 3 is that at 120 degrees, we have a full cycle of this. Now, it's a little bit tricky on this graph because where in the heck is 120 degrees? Well, let's chop this up a little bit finer. Pi over 2 is 90. So if I cut this into 1, 2, 3 parts, each of those little tick marks that I kind of inserted is worth 30 degrees. So if you think about it, this is 30, this is, you seeing that when I put a little dot there? 30, 60, 90, 120. So this length is the length of one period. I had to do a little bit of figuring there, okay? And those tick marks don't look equally spaced now that I step back from the board, but I was trying to make them look equally spaced. Just not the best drawer. Okay, I hope that's a little bit better. Okay, but anyway, this length is 120 degrees, or 2 pi over 3. So that's the length of the period. And we have a sine curve. In my packet, I know that sine looks like this. So I need that shape. I need it to go up 3 and down 3, and I need the hills and the valleys to be flipped over from each other. So here's the start, here's the end. That's this point and this point. The middle point is halfway between these, so that would be here. And now the hill is going to become a valley because of that flip, and it's also going to go down 3. So right to here, and then up from this dot to the 3, and then we draw in our curve. Okay. And then I could repeat that again and again if I needed to. Oftentimes I'll just ask you to draw one cycle, but sometimes I'll ask you to fill in the whole graph. Okay? Let's do one that's based on cosine and then we'll be done, okay? All right, let's draw y equals, let's say 1/2 cosine, and let's put this at a half as well. A graph of 1/2, okay? So the 1/2 that's out in front here, that's an A value, and that's telling me the amplitude. So this is a graph that's been squashed. It's only going to go up to a half and down to a half instead of going all the way to 1 and -1. And the other 1/2 is a B value. And we know that period is found by taking 2 pi and dividing it by B. Now here you need to remember how to divide fractions. We need to just remember to flip it over, right? And multiply instead. And so this would be 4 pi. So this is a graph that's much wider, much wider than typical. Usually we'd have a graph of cosine, don't draw this in, but there'd be a graph of cosine that looks like this. That's what it looks like in your yellow packet. But now it's going to take us twice as long. In other words, only that much is going to fit in the space from 0 to 2 pi. Only half the cycle is going to fit in the same space. That's what this 1/2 means. Only half the cycle is going to fit in the normal space. Okay, so think about this shape, and now you want to stretch it so it goes all the way out to here. Okay, so it's like this point has to be out here. And the other thing that has to happen is that the amplitude is a half. Okay, so now this point would be here, and this point would be here, and there'd be a point here. It would look like this, right? Because that's half of the cycle, and then the other half would have to be over here. So halfway, I'm just hesitating because I think my drawing looks kind of bad over there. Let me try that again. It doesn't, it looks like it went more than half a unit underneath the x-axis. I hope you know what I mean. My drawing abilities get in my way in this part of the year. Okay? All right, so this is a cosine graph typically. And what happened was, because our graph paper ends here at 2 pi, and because this should be 4 pi, we just have room for this much of the graph. And so the next cycle is this part. So what you're seeing on your own paper here is this, going up to the hill and coming back down, right? So you're just seeing this part of the graph, okay? That's a pretty tricky one, okay? Thanks for listening to this first video lesson, and please remember that when you do get to the second video lesson a couple days from now, in the very first few minutes, I call it video 1, but the next video is actually video number 2. It's what the typed label says on it. That's what's correct. I just misspoke, and I don't want to have to go back and redo the whole half hour. So thank you so much for listening to this one, and I'll see you in school.